Hello, everyone. Welcome to Unit 6, our proportionality relationship unit. We're going to be looking at the constant of proportionality in 6.1. So here we go. Liam is making breakfast for dinner using a pancake mix. How many cups of mix will he use for 12 pancakes? So if we look at our chart here, our table, it says 1 cup of mix will result in being able to make 12 pancakes. So 1 cup of mix, 12 pancakes. So with that same relationship, how many cups of mix will you use for 24? 2. 2 cups of mix will be 24. So what is the ratio of cups of mix to servings? We can do cups of mix first. So 1 cup of mix to every 12 pancakes. So that's our ratio. And we could also look at 2 to 24 and think about a fraction. 2 to 24, that could be, we could divide both those by 2, and that would result in a 1 to 12 ratio as well. Okay, so let's look at the relationship in some vocab terms. A relationship is proportional when the ratio of y over x is constant. The value of the ratio of two proportional quantities, it is represented by the equation k equals y divided by x, where y represents the dependent variable in a table or graph, and x represents the independent variable in a table or graph. So we're going to use the equation y equals kx to represent proportional relationships. Highlight or star or box in y equals kx. You're going to be using that equation a lot this unit. So here we go. We're going to practice in tables 1 through 3 finding the k value. So y over x. Y over x, I want you to also write the k value. So k value equals y over x. So y value divided by the x value. 6 divided by 1 is 6. So our k value is 6 here. Same thing here. 12 divided by 2 is 6. 18 divided by 3 is 6. 24 divided by 4 is 6. Are they all the same? Yes. So this would be a proportional relationship. So our k value is 6. All right, you pause the video and try 2 and number 3. All right, here's your answer for 2 and 3. So we got 5 as our k value for table 2, so that all have the same k value. So it is proportional. And then we got a 1/2 for a k value, or 0.5 for our k value for table 3. So those are also proportional relationships. All right, look at number 4. It says the cost of 6 pounds of almonds is $23.28. What is a constant of proportionality that relates y, the cost in dollars, to x, the number of pounds? So we're going to look at y equals kx here, along with finding our k value. So this is our equation, our proportionality relationship equation. So we always want dollars. So we want k equals dollars per pound. So what would we divide? It'd be the money, $23.28, divided by the amount of pounds, which is 6. And when you divide those two, you get a k value of 3.88. So on the left here, we're going to write our proportionality relationship equation. So y equals kx. What is k? It's 3.88. So 3.88x. That's our y equals kx equation. So that means that I can multiply 3.88 times x, which is pounds, and that would tell me the cost for any number of pounds with this relationship. All right, pause the video and you try number 5. Write your equation and find your k value. All right, here's my work number 5. So y equals kx. Our k value would be miles divided by hours. Okay, miles are almost always going to be on top, and time is always going to be the x variable, which is on the bottom. So 22 miles divided by 4 hours results in a K value of 55. That means this car, on average, is driving 55 miles per hour. So I can write an equation. Y equals 55x would be our constant of proportionality equation. Right now, look at number 6 in the back. We're going to be looking at a table now with a graph. So we need to plot some points from this table. So let's first we're looking at the total cost and number of tickets. So when we sell one ticket, how much does it cost? $10. So my X is my number of tickets. These are my X variables. And this is my Y. So when my X is 1, my Y is 10. How much does 2 tickets cost? 20. 3 tickets? 30. Might see a pattern here. In 4 tickets? 40. So let's find our K value now. Remember, K value is Y divided by X. So here it'd be cost per ticket. Cost divided by ticket. That's how we can show our K value, what it represents. So our K value here could be 10 over 1, which is 10. What does this represent? That would be $10 per ticket. You don't have to write your K value like this always, but I just want to make sure you guys understand like what this represents. What does it mean? And that actually answers part B. What does the point 1 comma 10 represent in the relationship? 1 was our X variable, which is the amount of tickets. Y, which is 10, is the cost. So 1 ticket costs $10. Okay, I want you to pause. I want you to try number 7. Write your variable, find your K value, and then and then fill out the table, and then answer the part B. Oh, and then also write your equation. So we should have wrote our equation for number 6. So number 6, our Y equals KX equation was Y equals 10X. All right, here's your answer for number 7. So I filled in my table. So I know there's also points for 5 hours, 6 hours, 7 hours, but we can just pick 4 points from the table. And I got a K value of 3. So miles walked divided by number of hours, you get 9 divided by 3, which is 3. So if you look at our point 1 comma 3, that represents 1 hour. It took 1 hour to walk 3 miles. Okay, I'm going to do number 8 completely. I want you guys to check your answers after I'm done. Now, if you think you're ready to go do the must do, go ahead and go try it. But this is for extra practice for the students that might need some extra support with this skill. All right, guys, here is the answers for number 8. Pay very close attention to the bottom questions here because on letter E, we're going backwards to find an unknown. So we're actually solving for miles instead of calories. We have to use division instead of multiplication. If you have any question about number 8, come talk to me, please, before you work on your must do. All right, guys, that is the end of 6.1. Good job, and go complete your must do and ace that mastery check.